Hi everyone, I am Dr. Shigar Kanti, Associate Professor of Mathematics, Government First Grade College, KR from Bangalore. In this video, we discuss about the nature of P series. P series is the series of this form, that is summation 1 by n to the power of P is called the P series. Now, we study the nature of this series. First, I will consider the case P equal to 1. If P equal to 1, then summation of 1 by n to the power P equal to 1 plus 1 by 2 plus 1 by 3 plus and so on. And we know that the nth partial sum is given by 1 plus 1 by 2 plus 1 by 3 plus up to 1 by n. And that sequence, that is sequence Sn is equal to 1 plus 1 by 2 plus 1 by 3 plus and so on is divergent. This already we have studied in sequences. Okay. So therefore, if the sequence is divergent, then the corresponding series is also divergent. That is, here if P equal to 1, then the P series is divergent. Next, I will consider P less than 1. Okay, next case I will consider P is less than 1. If P is less than 1, then n to the power of P is less than n. And if I consider the reciprocals, 1 by n to the power of P is greater than 1 by n. Now we know that this series by case 1, summation 1 by n is divergent. And summation 1 by n to the power of P is the series. Here, this an is greater than bn and sigma bn is divergent. Therefore, by comparison test, sigma an is also divergent. So that is here an is greater than bn, sigma bn is divergent. Therefore, by comparison test, sigma n is also divergent. That is here summation 1 by n to the power of P is also divergent. Next case, let P is greater than 1. And if we have m and n are two numbers here, and if m is greater than n, P is greater than 1, therefore m to the power of P is greater than n to the power of P. And this implies their reciprocals. 1 by m to the power of P is less than 1 by n to the power of P. Okay. Now I will consider this. 1 by sigma 1 by n to the power P. This is equal to sigma an equal to 1 by 1 to the power of P plus 1 by 2 raised to P plus 1 by 3 raised to P plus 1 by 4 raised to P plus 1 by 5 raised to P and so on. Now I will group the terms here. That is, I will take this as single term here, one term plus I will combine these two terms, 1 by 2 raised to P plus 1 by 3 raised to P. And here from this we can write 1 by 3 raised to P is less than 1 by 2 raised to P. Now here I have taken 4 terms here. 1 by 4 raised to P equal to 1 by 4 raised to P plus 1 by 5 raised to P is less than 1 by 4 raised to P plus similarly 1 by 6 raised to P is less than 1 by 4 raised to P. And 1 by 7 to the power of P is less than 1 by 4 to the power of P. That is here, these 4 terms, if I consider these 4 terms, these are less than 1 by 4 raised to P plus 1 by 4 raised to P plus 1 by 4 raised to P plus 1 by 4 raised to P. That is 4 times 1 by 4 to the power of P. Plus similarly here, 1 by 8 to the power of P equal to 1 by 8 to the power of P. But 1 by 9 to the power of P is less than 1 by 8 to the power of P. Similarly, 1 by 10 to the power of P is less than 1 by 8 to the power of P. So here I have taken 8 terms here. These 8 terms is less than 8 times 1 by 8 to the power of P. So that is, first term is 1 itself plus second term 2 times 1 by 2 raised to p plus. Next, this bracket is 4 times 1 by 4 to the power p plus. This bracket is 8 times 1 by 4 to the power p plus and so on. Now I will write this as this is 1 plus 2 to the power of p minus 1. 2 by 2 raised to p is 2 to the power of p minus 1. And this can be written as 4 to the power of p minus 1 plus. This can be written as 1 by a to the power of p minus 1. This is equal to 1 plus 1 by 2 to the power of p minus 1 plus 4 can be written as 2 square. That is 2 square to the power of p minus 1 or 2 to the power of p minus 1 square plus 8 can be written as 2 cube. That is 2 to the power of 3 to the power of p minus 1 or 2 to the power of p minus 1 whole to the power of 3. Okay. Then let me take this right hand side series as sigma bn. Okay. Now here p is greater than 1. If p is greater than 1, then p minus 1 is positive. P minus 1 is greater than 0. And this implies 2 to the power of p minus 1. So this is positive, therefore 2 to the power of p minus 1 is greater than 1. And this implies its reciprocal, that is 1 by 2 to the power of p minus 1 is less than 1. And here you can observe that the first term is 1, second term is 1 by 2 to the power of p minus 1 plus 1 by 2 to the power of p minus 1 square plus 1 by 2 to the power of p minus 1 cube. That is, this is a geometric series with first term is equal to 1 and common ratio is 1 by 2 to the power of p minus 1. Here we have 1 by 2 to the power of p minus 1 is less than 1, and we know that geometric series where the common ratio is less than 1, then that series is convergent. So that is, here we have sigma bn is convergent, and here we have an is equal to this one, 1 by 1 to the power of p plus 1 by 2 to the power of p plus 1 by 3 to the power of p. So that is, here the first term of an is less than or equal to first term of bn. Second term of an less than or equal to second term of bn. Third term of an less than or equal to third term of bn. That is, here we have an is less than or equal to bn and sigma bn is convergent. Therefore, by comparison test, sigma an is also convergent. That is, in this case, if p is greater than 1, then sigma an is convergent. That is, sigma 1 by n to the power of p is convergent. So that is, p series sigma 1 by n to the power of p is convergent if p greater than 1, and it is divergent if p is less than or equal to 1. So this is the nature of the p series. Okay, thank you. I will stop here.